everyone, so let's look at a couple of examples using exponential fitting. So basically you can look at your sequence of numbers and still find the finite differences, but by doing that you will notice, if it's an exponential sequence, you'll notice that it's exponential, that you basically multiply, it's going to have a common ratio, and then from there you can write like a general equation for the exponential and plug in the first couple of terms in the sequence to find the formula for the general term. Okay, so let's look at this one. So I have the sequence right here. I'm going to find the finite differences. So 7 minus 1 is 6. 25 minus 7, 18. All right, next one. 54. Next one. 162. Alright. 727 minus 241. 486. Next one. 2185 minus 727, 1458. Okay, so I noticed that everything divides by 6. Okay, so I'm going to do that, divide everything by 6. So we get 1, 3, 9, 27, 81, and 243. Good, and now you can see that this is exponential, right? This has a common ratio of 3, because you're multiplying by 3 to get to the next term. It's powers of 3. Okay, good, so that gives you a start. You're going to say the general term is equal to an equals a times 3 to the n plus b. So a and b are constants that you need to find, and we're going to find these by plugging in the first terms in the sequence. Okay, so a0 is equal to 1 and a1 equals to 7. Okay, so a0 equals to 1. You plug in 1 equals a times 3 to the 0 plus b. So this gives me the equation a plus b equals to 1. Next term in the sequence is a1 equals 7. So 7 equals a times 3 to the 1 plus b. So 3a plus b equal to 7. Okay, now we solve the system. Multiply this by -1. Negative a minus b equals -1. And we get 2a equals 6, a equals 3. And then b is going to have to equal to -2, right? In order to make that equal to 1. Good, so now we plug it into there. We have an equals 3 times 3 to the n minus 2. We can combine these to give me an equals 3 to the n plus 1 minus 2. Alright, and we start with a0. a0 equals 1. Alright, that's my first term in there. Alright, cool. So you can see how that finite differences also is helpful for exponentials. Alright, let's do another one. Alright, so we're going to look at this sequence. Start by doing the finite differences. So this is 4. This is 12. Now I need my calculator. 36. 108. And 324. Alright, let's divide everything by 4. Divide by common factor, just make your life a lot easier. We have 1, 3, 9, 27, 81. Right, powers of 3 again. This is geometric with a common ratio of 3. Alright, so we're going to take that and say our general term, because it's a geometric sequence, it's an exponential, it's going to be some constant, 3 to the n, plus another constant. Okay? We're going to use a0 equals 10 and a1 equals 14. So a0 equals 10. We have 10 equals a times 3 to the 0 plus b. So a plus b equals to 10. a1 equals 14. So 14 equals a times 3 to the 1 plus b. So 3a plus b equals 14. Alright, multiply the top equation by -1. Negative a minus b equals -10. 2a equals 4, so a equals to 2. And b has to equal to 8. Alright, so an is 2 times 3 to the n plus 8. This is the formula for that geometric sequence. And that's it. There we go.